Yes, dear participants, I welcome you to the lecture 53. Lecture 53 is on automation of micro irrigation system. We divided automation of micro irrigation system in 4 parts. So, first 2 parts we discussed. So, in the, if you remember, in the first 4 parts which we discussed about the first 2 parts. We discussed about the why to automate micro irrigation system, what are the role of ICT and IoT in micro irrigation automation, types of micro irrigation automation, parameters of MI automation and their components. So, in this particular lecture, we are discussing about networks for data communication and softwares, controller program, database, graphical user interface. This will be the components in this particular lecture. So, as I told you that this part network, it could be wireless or wired or hybrid of both for data communication, and then software, controller program, database, GUI. This will be the content of this particular lecture. So, just I am starting now. This is the this particular slide, basically it is giving what is the meaning of the different types of network which are used for data communication. So, what do you mean by the data communication? Data communication, it refers to the transmission of digital data between 2 or more nodes. Means here this could be connecting, this will be means your it could be connected with the computer, tab, sensors, controller, mobile devices. There could be several devices, it could be connected with a network. So, this is the part which is we call it as a data communication. So, when we are talking about micro irrigation, which is precision irrigation, and automation of precision micro irrigation is data centric approach. It requires a real time field data. These real time means what is the current status of soil moisture content, what are the weather data which are there. So, atmospheric temperature, relative humidity, wind, atmospheric pressure, there could be several data, and those data are used to correlate and then used for further processing and then operating the system. It involves the employment of these sensors to monitor the real time data, and then making useful information, means using those data from the sensor for planning the irrigation. Should we wait for few hours or should we give irrigation next day? Today it does not require. So, such type of information will be used after getting the data from the sensors. The physical connection between the network computing device is established using, it could be either wire by using the cables, or without cable or wireless, or it could be combination of both. Means some part it can be wireless and some part we are getting data by using the wire or cable system. So, when we talk of physical connection, these physical connections could be of 2 types. It could be wired connection, it can be wireless connection, and then these could be it involves a particular type of arrangement, how the data are means these different nodes they are arranged. So, here network topology is used. So, what is network topology? Network topology, it refers to the manner in which links and nodes of a network are arranged to relate each other, how they are connected and how they are means there is a relationship it exists between them. So, a network topology diagram helps to visualize communicating devices which are modeled as nodes and connections between devices which are modeled as links between the nodes. So, how they are connected and then the how means what is the link between them, they are used in this particular thing. So, these network topology, it could be of star topology, it could be bus topology, it can be ring topology, it has got all these have got their own meaning. So, mesh or hybrid means combination of all these or combination of two or more. So, when it says that star topology, so when we talk of the different types of network topology. So, when this is star topology is one of them. Here each device, you can see here it looks like a star and all these nodes are connected with a hub. So, each device or node is in the network is connected to the central device which is known as a hub. Now, star topology does not allow direct communication between the node, means it does not. So, one say here the node 1 is not connected with the node 2. So, it does not transmit information from one to other, rather information it is coming to the hub and then hub will connect, it will be connected with the 2 and the R pass on information to the 2. So, this be if one node, if one device or node wants to send data to other node device or node, it has to first send the data to the hub, then hub will transfer the data to the designated node or device. So, this is the arrangement. So, here we can see here, let us say that it could, here it is being shown as a 5, it could be more than 5. So, there will be 5 nodes and then the data from each unit, each node is being received by the hub and then it is transmitting. So, bus topology is the another way of arrangement. Here in the bus topology, it consists of the main cable and then the means they are arranged in a proper sequence, proper order, which looks as if they are in a order series they follow, and then it is in a bus manner and then there is a drop line. So, in a bus topology there is a main cable and all the devices are connected to this main cable through drop line. So, node 1, node 2, node 3, node 4, all this what we see, there is a drop line which is joining with the main cable. So, here all the data are transmitted over the main cable. There is a limit of drop lines and requires distance for the main cable, means main cable requires a distance as well as the length will depend upon the how many number of nodes are being used in the this topology. Ring at the if you see here, it follows a particular manner, means it follows as if it is in the circular manner. So, data from node 1 it goes to node 2, then it takes from the node 2 to node 3, from node 3 to node 4 like this, and there could be more than 5. So, in the ring topology, each device is connected with 2 devices on either side of it. Either side of it means one is connected with the 2 and then one is also connected with the node 5. So, in this system device sends data to another, but in one direction. Each device in a ring topology has a repeater. If the received data is intended for other device, then repeater forward this data until the intended device receives it. So, this is the way the ring topology it works. Mesh topology. So, in the case of mesh topology, we can see here that node 1 is connected with the node 2, node 1 is connected with the node 3, node 1 is connected with the node 4, node 1 is connected with the node 5. So, this is the type of, so all nodes are connected with the other nodes. So, each device or node is connected to every other device node on the network through dedicated point to point link. Network consisting of n number of node must connect with n minus 1 number with the nodes, means say this one it will be connected with the 4 excluding its own. So, n minus 1. So, we can say total number of links in a mesh topology will be n, that is the total number of node multiplied by n minus 1 divided by 2. So, simply I can say the total number of links, say in this case it will be 5 multiplied by 4 divided by 2. So, this will give 5 into 4 20 divided by 2. So, total number of links in this 5 nodes mesh topology will be 10. Hybrid topology means it is a combination of 2 or more topology is known as hybrid topology. Ease of scalability, as we can connect new computing network with existing networks with the different topology. So, we can see here it is a ring topology, it is a ring topology and this is a star topology. So, and they can be when both of them they are used. So, this such type of topology is known as hybrid topology. Each of means this is the each of scalability we can connect new means computing network with existing network with different topology. This is the case of, and in real sense in so when we are using, so we are using such type of topology in the system. Having learned the different types of topology, there are different types of protocols which is followed in the networking, and these protocol it is an established set of rules, means there are set of rules which is followed to determine how data is transmitted between different devices in the same network. So, it allows connected devices to communicate with each other regardless of any differences in their internal processes, structure or design. Similar to the way that speaking same language simplifies communication between two people, means it is the means language which is so means the idea is this one, that same kind of a data which are used are two different kind of a data which is used. So, when we are communicating each other. So, similar to the way that speaking the same language simplifies communication between two people, network protocols make it possible for the devices to interact with each other because of predetermined rules built into the devices software and hardware. There are some standard organization or institution which are using the different types of protocols, and they are designated for the different this kind of a thing. So, this is Institute of Electrical and Electronics Engineer, IEEE is one institution, organization, then Internet Engineering Task Force, IETF, then the International Organization for Standardization, that is ISO. This is in Switzerland, headquarter is available in Switzerland, and then the International Telecommunication Union, ITU, the World Wide Web Consortium W3C. These are the means groups or organization which are operating the setting the rules. There are different types of network protocols. So, one is the communication protocols, the another one is security protocol, management protocol. So, communication protocol, these protocols formally describe the format or and rules by which data is transferred over the network. Communication protocols also handle authentication and error detection as well as syntax, the synchronization of the communication and that is a semantics. So, say when we say call it as HTTP, that is hypertext transfer protocol, or when we say TCP, these are the terms which we are using. So, transmission control protocol. So, this is falling on these type of protocols are known as communication protocols. Security protocols, this type of protocol ensures no unauthorized users, services, devices access your network data, and this works across all data types and network medium being used. So, network security protocols rely on encryptions and cryptography to secure data, so that only special algorithms, formulae and logical keys can make this data. Now, the examples are SSL, that is a secure socket layer, or HTTPS, that is a secure hypertext transfer protocol. So, these are these protocols are which we read, these are the falling under the security protocols, means one cannot in the network enter. These protocols are being maintained. Management protocols is we come across the term called SNMP, that is a simple network management protocol, or ICMP. So, such type of protocols are known as a management protocol, and management protocol helps to define the policies, procedure used to monitor, manage and maintain computer network, that is essential for the stable communication and optimal performance across board. So, these are means that is the meaning of the management protocol. Here we are means from this particular diagram we are learning that how the wireless sensor networks it works, and that is how the automation is being done. So, we see here this is a farmland 1, this is a farmland 1, and then data communication we can see here the arrows are practically that is the how the data are communicating. So, we have a farmland 1 where the sensor is being used, and from the sense means data it is transferring by using the sensors and controller and actuator. So, it goes to the node, the different node, and then it will what it does that it is giving instruction, it comes to the base station. So, node 1 means here it is a node 1, and then it comes to the base station from the node 1, then it will go to the base station, and from the base station the data are coming to the node 2, where the again sensors and your data controllers are there. Some of the data which are required, it will go to the your server, and this it will be stored, and then based on the communication we will give to the server, it will again come to the base station, and then it will transfer to the your farmland and communication it is done. So, wireless sensor network allows faster positioning and integration of different types of sensors, as most of these network provide self configuration and self organizing, self healing and self diagnosing capabilities to sensor nodes. So, sensor node, this is one sensor node which has got node 1, and this is the another sensor node 2, and then finally it is being the information which you find here that it will come here. So, sensor data are transmitted, then it goes there, and then the pump or electric motor whatever is there, it will actuate based on the control. So, communication via, so this could follow a particular type of system, that is your WSN, W means Wi-Fi, WiMAX, Bluetooth, mobile network. Depending on that will be used to do the instruction, and then the data will be accordingly programmed, and then it will do like this. So, when we call it as a wireless sensor network based automation, commonly used technologies could be LoRa, Zigbee, Wi-Fi, Bluetooth, GPRS, 3G, it can be 3G, 4G, 5G, now 5G likely to come, and then your worldwide the interpretability for microwave access, that is WiMAX. So, these are the standard for these the commonly used technologies. So, standard for this if it is LoRa, it is coming under the IEEE. So, according to the IEEE, the frequency band which is specified in this range, that is a 433 megahertz to 868 megahertz, that is used in Europe. And then like this our India particularly for our India, IEEE has specified the frequency band for the LoRa, it is between 865 to 867 megahertz. It has got the transmission speed of 0.3 to 27 kilobyte per second, and then the communication range is 10 kilometer plus in the perfect condition. Power it requires low power consumption. Like this there are other the commonly used communication technologies. So, this could be the Zigbee. So, as per IEEE, this particular this is the standard it follows, and then this is the thing, then Wi-Fi, this is another standard. So, like this there are different standards, and accordingly the for these technologies which are used, say in case of Wi-Fi. So, Wi-Fi is being according to the IEEE 802.11 ABGN standard. It means this is the standard which follow, the frequency used is 2.4 gigahertz, and then this is the data transmission, that is 2 to 54 megabytes per second, and this is the communication range, that 20 meter to 100 meters. So, if you see look into the different cases, it is the LoRa, it has got the 10 kilometer plus, and here it is the in this case the microwave access, this is 50 kilometer, practically 10 kilometer. So, this is the way it is being expressed. What are the different advantages of wireless sensor network? It is easy to install, that is one advantage. So, low cost scalability is possible. So, easy to install means a quick straightforward installation is one of the main benefit of wireless sensor system, and then wireless systems are only viable option where hard writing is difficult or impractical. For example, remote large agricultural fields, heritage building, etc. could be, this is the another thing that it could be, means the where this can be, used. Low cost, initial installation cost and components are cheaper than wired technology. With this advancement of the wireless technology in the long run, and also maintenance cost is also low. It can be, scalability, it can accommodate any new nodes or devices, means that can be included, and it can be implemented at a very short span of time. The other features of the wireless sensor network is self organization, means wireless sensors network autonomously determine its very own configuration parameters, including addressing, routing, clustering, positioning, and then power control, etc. It has got flexibility in mobility, means flexibility in the sense that it is mobility, means it is one can easily reposition sensors to get a stronger signal, and if situation demands, node can be moved in a limited distance without any additional changes. There are some challenges in wireless sensors networking. Those challenges are to be addressed by researchers, and then that should be taken care while someone is using wireless sensor networking. So, one challenge is energy consumption. Power consumption is one of the main issue. Battery or solar power is used by equipping with sensor nodes. So, we need a solar panel or battery, and then if there are some places where such problems it comes. So, the availability of power, solar system, that also a problem it comes. Energy consumption mainly depends on the sensors nodes operation, like communication sensing and data processing. Clock synchronization, it is a it is a serious system service system problem in the wireless sensors network. The main function of this synchronization is to offer an ordinary time scale for the nodes of local clock within the sensor networks. Such clocks must be synchronized with some applications like monitoring as well as tracking, means this should go simultaneously. Another challenge is quality of service, means an interference. So, quality of service means quality of it is the data must be distributed in a regular time frame and then in accurate manner, because some of the real time sensor data sensor based application mainly dependent on time. So, if the error free data is not distributed on time towards receiver, then data will not be useful. This is the another important thing, means if the data received and then there is a time gap. So, this may not be useful. Then interference, if there is any other electronic wave like high voltage electric line or other wireless sensor network, industrial activity that involves the electromagnetic means waves which are working there, means the such means lines. So, these are present. So, these are likely to put interference. So, this should be taken care, or we need to change the system accordingly. Physical security of the device, as this network these networks are deployed in the remote or unattended areas. There is a high chance of theft, damage, external natural forces as well as human and animal. So, that is the another threat and one should take care about this part. So, it is a big concern to protect our network system. Data spoofing any wireless network is very high risk of network hacking and data spoofing, and this is a common problem. So, this should be taken care while we are going for WSN. Now, software controller program, database and graphical user interface. So, here the hardware components are operated by software, and there are mainly 4 components that are used in modern day, that is your agriculture system, which is the major component is a microcontroller program, cloud platform, database, web server and graphical user interface. So, microcontroller program this your microcontroller is a programmable IC that is which is capable of multiple function depending on how it is programmed. So, typically they are programmed with the high level languages such as C++ or Java, and that is one of the essential tool design program, and the IC means your integrated development environment, that is IDE. So, microcontrollers means understand assembly language instruction, how their instructions are set, and these are high level of this involves the high level of programming languages, and these these could be uploaded, and the examples of the microcontroller is Arduino with the this, that is your integrated development environment with C++ program. Cloud platform, and cloud platform allows a network of devices to be operated through the cloud based network, and the cloud computing is on demand applicability of the computer system resources, especially data storage, computing power without direct active management by the user. So, some of the platforms, these cloud platforms are Amazon Web Service IoT platform, Google Cloud IoT platform, Microsoft Azure IoT Suite, IBM Watson. So, these are the cloud platform which is being used now when the data size is large. Database is the collection of the information, that is the these data are organized such that it can be easily accessed, managed and updated. So, means these data could be aggregation of the set of files, then means it could be huge data record, and then typically it means the data manager, database manager provides user the ability to control, read or write access. In a smart irrigation micro irrigation systems, sensor data are stored in the database for intelligent decision making and for future reference. So, these database also hold current status of actuators. So, these database examples are Oracle, Microsoft SQL Server, MySQL Server. These are the different server which can be used for the database storage. Web server, it is the another important component. Web server is a computer software and underlying hardware that accept request via HTTP, the network protocol created to distribute web pages or its secure variant HTTPS. A user agent, commonly a web browser, a web crawler, initiates communication by making a request for a specific resource HTTP, and the server responds with the content of that resource or an error message. Server can also accept or store files. In e-agriculture, end user make request for the real time farmland data that is served by this web server. So, end user can also monitor and control actuators by making requests through web server. So, examples are Apache, IIS, this your Nix, GWS, Cloudflare. These are the examples of this one. Now, here what you see, the graphical user interface means instead of giving the data or files or text, this is in the graphical way it can be shown, that becomes for any person to use, understand properly, even a farmer can operate. So, GUI displays object that conveys information in represent action that can be taken by the user. So, this is in the interactive mode this works. So, object changes the color, size, visibility, so that it can be easily, this is just what you are seeing here, and the soil moisture content, it is being shown here, this the humidity, and we can show here the temperature data. So, such type of information this is displayed, and that becomes for the graphical user friendly system, it works. So, the GUI objects include icons, cursors, buttons, and these graphical elements are sometimes enhanced with sound, visual effects, buzzing sound or visual effects like transparency or and drop shadows. Apps, web pages are the common form of GUI for smart irrigation system. So, these are the references. You can refer these references for more detail about this lecture, and we discussed in this particular lecture network for data communication. We also discussed different computer program, database, graphical user interface, and in the forthcoming lecture part 4 we will discuss about the other aspect of this particular system. Thank you very much.